Hello everybody, this is the lab for bonding in chemicals. And so we have 5 different chemicals. Everything is a chemical if you really think about it. We've got sodium chloride, basically table salt. We've got our unknown, and if you see that little pink thing there, you probably know what the unknown is. We've got our copper filings. These are actually copper crimps, because I could not find filings. We've got our iron, and that's basically it's an iron alloy, it's close enough. And we've got sucrose, which is also sugar. Showing off the Peruvian connection here. So what we're going to do is we're going to do a couple of experiments. We're going to see how well these guys melt. We're going to see how well they dissolve. And then we're going to see how well they conduct electricity. So let's get started. Let's go ahead and turn this guy on. This is coming to you live from a secret location. So we got our fire going. Let's go ahead and get our iron filing out and just heat it up, see what happens. Let's see if we get any kind of like color change, any kind of sign of melting here. So I don't know if you guys could see that very clearly, but the tips of my tongs do have a color change, but the screw itself pretty unmelted. So probably need a stronger flame for that. Let's go ahead and use some of the copper. Right? Hopefully we can all see the color here. Nice coppery color. Go ahead and put that next to the flame. Ooh, it's getting redder. So I'd say we're getting pretty close to like a melted. Nice little burnish on that. That's pretty cool. So I'd say that would melt if you give it enough time. I'm trying not to damage my secret laboratory equipment here, and so I'm not going to actually try to melt these guys. Next up, we'll go ahead and grab some of this sucrose. So I'm kind of going out of order, but there we go. Sucrose. See if that melts. So we can actually see something happen here. Yeah, you guys could see that. We're getting signs of melting. That's pretty nice. Go ahead and put that off. Next spoon. Let's go ahead and grab our unknown. Get some of this green colored stuff. I feel like this guy should probably melt. Let's find out. Would you call this melting or burning? Interesting. I'll let you guys decide. And last but not least, let's get some salt out here. Fortunately, I'm not playing Call of Duty right now. Otherwise, I'd have all the salt I need. Let's go ahead and actually just put this guy down for a bit. And grab our salt some other way. There we go. A good amount of table salt right there. I've made a mess. Unavoidable when it comes to science. Let's go ahead and just see if that melts. Yeah, given enough time, I don't think it's melting. All right, So that takes care of the melting process here. Let's just go ahead and turn this guy off. Next up, we're going to see if these guys dissolve. So here we have some nice DI water. This is deionized, meaning it has no other particles of anything inside of it. This is just regular old plain water. You actually can't get this stuff from the tap. Your tap typically has waters inside of it. So let's go ahead and see if this dissolves. I have a strong suspicion that the salt will dissolve. Let's go ahead and do some crushing here. There's the salt. Yep, that looks like it dissolved. Next up, see if the unknown here is going to dissolve. There you go. Sorry if the camera work is a little bit shoddy. Okay, if we get this long enough. Well, looks pretty dissolved. Let's put this off to the side and get the last one in here. So let's see if the sugar dissolves. That actually dissolves very quickly. I'm going to drink this one later. All right, and then just for kicks, why not go ahead and try and see if either the iron or the copper dissolve. Let's just use the tongs. And you know what? I don't think if I stirred on from now until forever, I don't think the copper or iron would dissolve in water here. So we'll just leave those off. Next up, so that finished the dissolving part here. It's about what you expect. So next thing up, we got to see if these guys conduct electricity. So I'm going to go ahead and put these guys down finally, or at least the camera, I mean. Go ahead and angle that properly. There we go. And so in order to conduct electricity, you're going to need a source of electricity, and that's what I have right here. A little 1.5 volt battery. Let's go ahead and see if I could focus in on that. Whatever. So we're just going to see if we could conduct electricity through any of these solids. I got a nice little multimeter here. It's kind of old, kind of dusty, but it's actually my dad's, so I felt like I needed to have brought this along with me. And so if we just take the tips here, there's no real way to show you this. I only have so many hands. Well, I'll just read it out to you guys. If I put the leads on here, I have a voltage of about 1.6. And so that tells me that this battery is alive. Good. Let's go ahead and do some testing here. We'll put the battery down. We'll take a screw and put it onto either end. And this way, we'll be able to see if we are conducting electricity. Let's go ahead and just test, or just touch. 1, 2. Oh. You need some steady hands here. But yes, I do get some conductivity. The value is about 0.3. So yeah, I'm getting some conductivity here. Put that away. Let's try some copper. Same deal. Hopefully you can see I have the copper crimps just off to either side here. We're just gonna put these guys in and see if they conduct. And wouldn't you know it, we do get some conductivity. The highest I saw right now was about 0.8. So it's a good transference of electricity here. Not bad. All right, next up, we want to see if these solids will actually conduct electricity. And so I'll just go ahead and sprinkle some sugar off to this end. Sprinkle some sugar here. The wife is not going to like this mess, but it's for science. So we've got crystals of sugar on either end here. Hopefully it's visible. Go ahead and put those guys in. And we get some numbers going through here, but the voltage is staying pretty much at 0. So that's a dud. Let's go ahead and just brush this guy away. I should have used a boat, but I chose not to. Go ahead and sprinkle some of this stuff in, our unknown. All right, so touching both ends here gives us a huge nothing. So same deal, nothing gained here. Again, the mess I'm making is for science. Let's pour some salt on either end here. Great. And make sure it's visible on camera, and it is. So again, we're just checking to see if they conduct electricity. Nothing. So, go figure. These 3 powders do not conduct any electricity, while the metals do. Let's go ahead and see now if they conduct electricity in water with the dissolved particles in them. So here's our salt. Let's go ahead and put that in. And so does this guy conduct electricity? Just immediately? Yes, we're getting some voltages here, about 0.20. So it's not very good, but it is still doing conduction. There we go. Let's go ahead and put that battery away, dry it off. Let's get the next fluid out. Get the battery again, dump it in here. And does it conduct electricity? Throw that down there. And yes, we are getting some conduction. That's awesome. I've also dirtied my leads here, so I'm just going to go ahead and clean those guys off with another towel. Same thing with this guy. Make sure this guy is clean. There's no real need to conduct electricity through these metals. We already know they conduct electricity, and they don't dissolve in liquid, so these guys don't conduct electricity. And so let's do the sugar last. Put this front and center. Does it conduct? Oh wow. This one conducts a lot. The voltage is about 0.3. And so we have our results here. If you didn't follow along, that's fine. Just use a yes or no for whether or not conduct electricity. But if you're following along and you got the direct voltages, please do so. If I recall correctly, this guy, the salt, was about 0.2. Also about 0.2 for the unknown. The sugar was about 0.3. The copper was about 0.8. And the iron was about 0.5, if I remember right. And so that brings us to the end here of these little experiments. I wish I could do this in class, but the times limit our abilities here. If you're interested in trying this experiment at home yourself, you need a multi-tool or a multimeter in order to do this. It just conducts electricity, or just measures the amount of voltage in a material. I got this at Home Depot for about $8. So it's very easy, very manageable. If you ever intend to be any kind of engineer or handyman or just involved in the industry here, you're going to need this eventually. Also, a very useful tool. All right, that takes us to the end of this experiment. Hope you enjoyed. Mr. Azad will see you back in class soon enough. Bye-bye.